Okay, I'm just going to run through a not with you because a not is quite an interesting thing. Imagine a not function in Excel, like a kid who's playing opposite day. Whatever you tell it, it's going to claim it's the opposite. So let me show you now. You know when you're using an if, and you basically ask it if this is equal to this, and it'll effectively tell you if that's true or if it's false. Now, as we know, we can put like words in there to say this isn't equal to this and so on. Well, basically, that's what it's doing when you do that. If A3 is equal to B3, true, otherwise false. As you can see, 10 is not 5. And when we pull this down, it makes perfect logic sense. 10 is equal to 10. 5 is not equal to 10. Right, this is where not comes in. Not acts like, as I said, a kid playing opposite day. Whatever you're going to put in here, it's going to tell you it's the opposite. As you can see, we ask the logic to be evaluated. Are these two equal? And then we put them through the not, and it turns it the opposite way around. So before we had false, because 10 is not 5, but this time, because we have a not, it actually returns true. When we pull it down, you'll see that those statements have now been reversed because of the not function. What we can do then is we can basically say that we can say 10 is not equal to 5. And can you see how that's coming from there? It's basically pulling the not logic. It's true that it is not. 10 is equal to 10. But because we're interested in the not, it flicks the logic perfectly around. And again, 5 is not equal to 10. And it's that simple, really. We're really asking if something is not the same. That is the key part of this. And that's the idea of it. We need to know if these are not the same to actually tell us what to do next. Okay, moving on down then, you can see what's going to happen when we head into the less than. So if I were to turn around and say less than, again, you can see 10 is not less than 5. It's true that it is not less than 5. Again, we're going to roll that down and we can see the same logic, can't we? Yeah. Again, 10 is not less than 10. And we just roll that on and then we look at the number 5. Well, 5 is less than 10, so it's false. It is the opposite. And that's how we decide. It's really if the equation results in a false, it flips it upside down. Whatever the actual outcome, it turns it on its head. It makes it the opposite. The same can be said when we move into the greater thans. Same basic logic. You can see not doing anything completely original here. And you can see from this you get a kind of pattern developing. When we head into the greater than or equal to's, we get the same basic logic. Can you see? 10 is definitely greater than 5. It's true that it is, hits the not, flicks it on its head. When we ask is 10 greater than or equal to 10, 10 is greater than or equal to 10, hits the not, flicks it on its head. Again, 5 is definitely not greater than or equal to 10. That's true because it flicks it on its head. Dead simple stuff here, and it's nothing too much to wrap your head around. You just got to remember that whatever goes through a not, it turns to the opposite of what was originally there. You should be able to fill out these little descriptions yourself from this and see if you get them right. But as you can see, it's really, really simple. A not is just a function that takes an equation, works out if it's true or false, and then flicks it on its head. Now, there's nothing much more to it than that. In a different session, we're going to show how to combine this with an if statement to actually make it say different things and make proper decisions.